In this lesson, we're going to learn about powers and exponents. We will learn how to evaluate an exponential expression, and we'll also be able to write repeated multiplication as a single expression. Exponents is just a shorthand for repeated multiplications. So like if we have 2 times 2 times 2 times 2, we are repeating multiplying by the power of 2, but we can write this in a quicker way in shorthand as 2 to the 4th. The term powers and exponents are interchangeable. So let's go over the parts of an exponent or a power. So here we have 8 raised to the power of 2, or 8 squared. 8 is our base. It's the number being multiplied. It is also called the factor. And 2 is the exponent. This tells us how many times we are multiplying the base of 8. So this is 8 times 8, which is 64. Let's take a look at this example, 2 to the 4th power. What do you think the most common mistake would be for someone to evaluate 2 to the 4th? Most of the time, if somebody gets this incorrect, they simply multiplied 2 times 4 to get 8, which is not correct. So let's take a look at a good math practice that will ensure that we get our answer correct. So 2 to the 4th, we have a base of 2. This is our factor. This is the number being multiplied, and we are multiplying it 4 times. So let's expand this expression. We have 2 times 2 times 2 times 2. So now when we evaluate this, we will multiply 2 times 2 to get 4. We have another 2 times 2, which is 4. And then we multiply these and we get a value of 16. So 2 to the 4th is 16 and not 8. So if you ever get confused, simply expand this base this number of times and then multiply it through. So now let's take a look at the pattern of what's going on. So this is the power of 2. So 2 to the 1st is simply 2. 2 squared, if we expand it, is 2 times 2. 2 to the 3rd is 2 times 2 times 2. 2 to the 4th means we have 4 2's being multiplied. And then 2 to the 5th means we have 5 2's being multiplied. So our product increases exponentially. When we have exponents, it gets large real quickly. So the product of 2 to the 1st is 2. The product of 2 squared, we can see, is 4. The product of 2 to the 3rd is not 6. It's 2 times 2, which is 4, times 2, which is 8. Then we have 2 times 2, which is 4, times 2, which is 8. And then 8 times 2 is 16. And then we have 2 times 2, which is 4, times 2, which is 8, times another 2, which is our 16, times one more 2, so it's 16 times 2. That gives us 32. So 2 to the 5th, again, is not 10, but 32. So expanding really helps in evaluating exponents. Now let's take a look at the pattern. How are we going from 2 to 4? Well, we're simply multiplying by 2. And then 4 to 8. 4 times 2 is 8. Then from 8 to 16, when we move up an exponent, we're multiplying by 2 again. And then lastly, we're multiplying by 2 again. So each time we have multiplied by another 2. So again, our products increase very quickly with exponents. Let's take a look at this pattern. 3 to the 1, we just have 1 3. 3 times 3 is 3 squared. Then we have another 3 we're multiplying. On 3 to the 4th, we are multiplying 3 by itself 4 times. And then we have 3 to the 5th. Okay, so now let's get our product. And we know 3 to the 4th is 3. 3 times 3 is 9, so 3 squared, again, it's not 6, but 9. 3 to the third, this is 3 times 3 is 9, times another 3 is 27. And when I have even amounts of factors, I like to just multiply 2 of them, and then multiply those products. So 3 times 3 is 9, 3 times 3 is 9, and then I know 9 times 9 is 81. And then we have 3 times 3 times 3 times 3 times 3. So it's 81 up to this point times one more 3, which gives us 243. And again, our base is 3. That's what's being multiplied. So the pattern from 3 to 9 is times 3. 9 to 27 is times 3. 27 to 81 is being multiplied by 3, and so forth. So again, we're increasing very quickly. So you take a moment, pause the video, expand these, and then provide your answer. Okay, now let's expand our factor of 5, our base. 5 times 5 is 25, times one more 5, and that's 125. So 5 to the third, or 5 cubed, is not 15, but 125, a much larger value. When we expand a power of 10, it's pretty easy. So 10 times 10 is 100. We have another 10 times 10, which is 100. We multiply these together. And then we have this last one. So we end up getting 100,000. Now let's multiply out. We have 4 times 4 times 4 times 4. And I will remind you that in this unit, we will not be using a calculator. So you have to do everything by hand. Okay, so we have 4 to the fourth. So I'm simply going to multiply these pairs of 4 to get 16. These pair of 4 to get 16. And then 16 times 16 is 256. If you did not know that, you could work it out by hand. Okay, now we have a fraction raised to the fourth power. So we have 2/3 being multiplied 4 times. So we're going to just multiply straight across our numerators. 2 times 2 is 4, times 2 is 8, times 2 is 16, over 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. So we get 16 over 81. Okay, now let's talk about a negative base. This is super important. So remember, the base is the number being multiplied, and every base has its own exponent. So this is negative 3 to the fourth, meaning that this exponent 4 is only attached to the 3, not the negative, just the 3. Where in this case, because we have parentheses, meaning the negative is included as part of our base, so the base in this example is negative 3. The base in this example is simply 3. So what does that look like when we expand? So we're going to have negative, here's our negative, you can't just leave it, and then we have 3 to the fourth. So we're going to say 3 times 3 times 3 times 3. So we only have this one negative out front, so our final answer will be negative. So we're going to have negative, and then we have 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. So our final answer is negative 81. Now, when we expand this factor, remember, negative 3 is the base. Negative 3 times negative 3 times negative 3 times negative 3. So I'm going to multiply these two negative 3's to get positive 9. I'm going to multiply these two. Negative 3 times negative 3 is positive 9. So we end up with positive 81. So notice the difference in our answers. When parentheses is provided, it includes everything within that parenthesis as part of the base, so that's what you expand. So let's remember, when the base is negative and parentheses are provided, we will expand the negative. So this base is -2, and we are multiplying -2 4 times. And then I'm simply just going to go through, and this gives me +4 times +4, which gives us 4 times 4 is 16. Now we have -3 to the third, and -3 is the base, so the negative gets expanded with it. So we have -3 times -3 is +9. And then we have 9 times this -3, and this gives us -27. So you still can have a negative answer when negative is included. It just depends on how many times you're multiplying it, whether you end up with a negative or a positive. Our base is -5, so we're going to expand -5 2 times, and we simply get +25. Now, as you can see on these problems, there are no parentheses provided. This means that the base for this first one is 2 with a negative attached out front. And so we have the negative, and then we simply have 2 times 2 times 2 times 2. So I automatically know my product is going to be negative. So we know 2 to the fourth is 16, and it's negative. Here we have the attached negative, and we're going to expand 3 to the third. Our answer is definitely going to be negative because of our negative just attached out front. 3 times 3 is 9, times 3 is 27, and again, -27. Our last example, our base is 5 with a negative attached. So here's the negative attached. Negative is not part of the base. I only expand the base. Again, this negative is going to automatically transfer to our answer, and we have 5 times 5, giving us a final answer of -25. Now, you do not have to memorize this at all, but some of you probably already noticed a pattern, excuse the bell. Every time that we have parentheses with a negative, the products that are positive are those that are raised to an even exponent because it ends up making a positive product. So if you can remember that, that's fantastic, but you don't have to memorize it because you can simply expand and go through the math, go through the steps. On these ones, notice all of the products are negative. So when you just have this little attached negative with no parenthesis, you're automatically going to write it as part of your answer. So you can pause the video and jot this in your notes. Okay, so pause the video again and write these in your notebook, give these a try, and then come back to check the answers. Okay, on number 1, our base is -6, so we expand -6. And then we're going to multiply. Negative times negative is positive, so that's +36 times -6. So a positive times a negative is negative, and then that gives us 216, so -216. Number 2, the negative is not part of your base. 10 is your base, so you're only going to expand the 10, and you're going to just attach the negative out front. So, whoops. So we know we're going to have negative. Let's erase that. So we know that we're going to have a negative answer. So we have 10 times 10, and then another 10 times 10. So that gives us a total of -10,000. On number 3, our base is 7 with an attached negative that is not expanding, meaning we will end up with a negative product. So we get negative 49. Number 4, the base is negative 5, meaning we expand the negative as well as the 5. And so we get negative 5 times negative 5 is positive 25 times positive 25, and that yields 625. Now let's talk about given an expression and writing it as an exponent. So here we have 3 times 3 times 3 times x times x. So we can write this. We have 3 multiplied 3 times x raised to the second power. Our next example, we can write this 2 different ways. We can simply write, we have 2y multiplied 4 times, and if you write it this way, you have to include parentheses. I'll show you why you would get it wrong if you don't include the parentheses, raised to the 4th. Or you could say 2 times 2 times 2 times 2, so that's 2 to the 4th, times y to the 4th. So either of these are correct. What you cannot do is say 2y to the 4th, okay? Because this is saying that I just have 1, 2 being multiplied because it has an understood exponent of 1, but I have 4 of them. But this 4, without a parenthesis, this 4 is only attached to the y. So make sure you do not write it this way. Our third example, negative 8 times negative 8 times negative 8. The negative is included with the base because it's expanded as well. So again, we have to have negative 8 in parentheses raised to the third power. If you write negative 8 to the third, this is incorrect, okay? So make sure that everything that's being repeated the same amount of times, you include that, and if necessary, use parentheses. In this example, we can see that we just have an attached negative, and we have the base of 7 multiplied 1, 2, 3, 4, 5, 6 times. So it's negative 7 to the 6th. Okay, pause the video, and then when you come back, we'll go over these. Okay, on number 1, again, there's 2 ways that we can write it, and one way we definitely don't need to write it, which is a common mistake. So the first way is we could say 5 to the 3rd times a to the 3rd. Or since we have 3 5s and 3 a's, we can say, and with commutative property, you can arrange your values however you want, your factors however you want. We can say 5a to the 3rd. What you cannot have is 5a to the 3rd this way. You have to have parentheses because 5a to the 3rd just says that there's one 5 factor and 3 a's, but we have 3 5s going on. Number 2, the same way. We can say 4m, those are together, raised to the 4th power, or 4 to the 4th times m to the 4th. You cannot have 4m to the 4th because this, when we don't have an exponent written, guys, if we don't have an exponent written, because every factor has an exponent. If there's one not written, it's understood to be a 1. And this is saying 4 to the 1st, but we have more than one 4 being multiplied. Number 3, we have negative 9 to the 3rd, c to the 3rd. That's one way you could write it. This negative is not part of the base, so it doesn't need parentheses. Or if you do want to use parentheses because we have 3 9s and 3 c's, you can say negative and then 9c to the 3rd. Either of these is correct. Number 4, negative 2 is the base raised to the 4th power. Number 5, we can have 1/2 raised to the 3rd. And when you have fractions, guys, you have to use parentheses. You have to. Okay? You cannot write it this way. Okay? You can't do it like that. every fraction has to have parentheses with an exponent, times k to the third. Or you can put it all together and raise it to the third using parentheses around both the 1/2 factor and the k factor. And lastly, we have the attached negative that is not part of our base. So 2/3 raised to the 1, 2, 3, 4 power of 4.